Okay, so in previous lecture, basically, I show you how to read farm history and farm drug risk. The farm drug risk is for the scoring, and that's why the farm scoring, the data frame, the farm drug risk does not have the column for what? Column for the crop damage, right? Okay, so this is going to be used for scoring. And then the last column, all the values in the last columns are coded. No damage 1, mild 2, and then moderate is a 3, and then severe is a 4, right? Okay, and then we set these the filters, right, input columns or independent variables, and then the crop damage, the column crop damage is dependent variable. This is target value or the label. Okay, so up to this point, we're gonna use this, you know, this code, right, will be used for the LDA, and then KNN and NB, knife-based method, right? Okay, so now let's talk about LDA. And basically, we input this method, linear discriminant analysis method, and then we write from this package, scikit-learn discriminant analysis. And LDA is what? LDA is alias. So from there, we create the model, LDA model, right? And then we apply the fit functions. The fit function, right? The first argument for the fit function is independent variable, which is this. And then the second argument for the fit function is dependent variable, which is crop damage, right? And then we apply this. We train the model, right? And then we get the fresh data frame from farm drought risk. So basically, this is for the scoring, right? So we get a new fresh copy of copy from farm drought risk for LDA. So the original data frame is not altered or changed. It's original data because we're going to use it for the later, the method, right? KNN and NB, right? Base NB, right? So we call it LDA output. So we get a new fresh copy. And then let's take a look at this value, and you know that it's 1. Basically, it's a farm drought risk, same as you know that it does not have what? The target column, the crop damage. Okay, then once we have a fit, then next step is to predict, right? So if you look at the predictions and LDA output, so this is going to be the input for the prediction functions, and these values are predicted, right? These are predicted values. So the 2 means what? 2 means a mild, right? Okay, so this predictions. So next step is obviously we're gonna add new column called crop damage to the LDA output, right? Since LDA output doesn't have a crop damage column, and then these values, prediction values, basically the values for the new column called crop damage. And so they apply to list, and then they make all of them a string. Okay, so the result is what? Result is you see that crop damage is added to this LDA output, right? Then it has all these values 2, 1, 3, 3, 2, right? I just want to look at a couple of them. Because this is long, I don't want to see all the rows. Okay, and then the next step is we're going to convert, because it's not really human real, right? So what we are going to do is we are going to change this value to, for example, for 2 to mild, 1 to no damage, and 3 to moderate, and etc. So they use lock, right, for that. So LDA output a lock, and then first argument is for the row, right? and then comma, and then this is a column, right? So the crop damage is a crop damage column. Then every row which satisfy these conditions, right? The value of that specific cells are what? Basically, the value is going to be the no damage, right? For specific cells which satisfy these conditions, right? Okay. So, for example, if LDA so every row that has, let's just let's just look at this example, right? So now let's look at this one. Okay. So that means every row which satisfy these conditions, crop damage is equal to 3. And then the column name is crop damage. Basically, in this case, this guy and this guy, right? There's two of them basically satisfy these conditions. Then this value is going to be what? Changed to a moderate. This will be changed to moderate, and this will be changed to moderate. Okay? So we're using a line to specify, to denote a specific sense. Right? They're using a line. Okay. And then now let's take a look at it. Once you run and execute this code, you'll see that there's a change, right? Now there's no longer a number. Instead, you see mild, no damage, moderate, moderate, and mild. Okay, and it's simple. Okay, and when you see the couple of lines, okay, then you apply a very useful function, value count, and it shows that among all the rows, there are about 314 rows for the moderate, and 65 for the severe, and 56 mild, and finally 27 for no damage, right? And then you can look at the percentage of this value. If you have a new argument, right, called normalize is equal to true, right, then it shows that the percentage for each value. So for example, 314 is about 0.67, like 67%, right? And for the severe case, it's about 14%, so 65 basically the same as 14%, right? Okay, so etc. And if you have problem number 3, they ask, to find a row labeled with the number 32 of the scoring data set. So that's the scoring data set is LDA output, and then I use a lot. And without anything, without any comma, right? Basically, this means a row, right? Row, right? So they're using what? They're using basically the log, they're using index, right? Index number. So index number is the index label. So for example, if you look at the previous example, this is index, right? 0, 1, 2, this is index. By the way, this index is not a what? Actual integer value. This is just a label, okay? So that's why I'm using the log. Okay, so 320 of the scoring data, right? The labels, right? The last is that if he wants to predict a specific, if he wants to, predict the output of a specific input, the individual, for example, right? You can also use the predict function. If you look at the predict functions method, actually, let's see, yeah, they take data frame as an input, right? But I want you to know the predict functions. This predict method can also take individual, row. Like for example, let's say, let's take a look at this row with the label number 4. So the data is what? This is the input data, right? So let's just copy, and then you can paste, Control V, right? Okay. So I want you, okay, so there's a couple of things I want you to know. So let's say 0, 21, 15, and so that's a input value, right? And then please, when you put the specific value, you have to use a two-dimensional array. That's why I use a square bracket, right? So the predict usually take what? Two-dimensional array or the list as an input. So that's why I put those two double square brackets. Okay, so when you run this, hold on. Oh, predict. Oh, I sorry, we just have a one more square bracket. Okay, so this is good. Okay, so it shows what? It shows that number two, right? And please ignore this warning sign because they're, basically kind of complains that I don't have this doesn't have a column name, the attribute name, but it's fine. You can ignore the warnings. But actually, what is the output? Output is a two, right? So two means what? It means the two means the mind, right? So it's mind. Okay, so we use this input, specific input, right? Individual input, and then the predict value is mind, right? Obviously. Okay, so that's why you got number two. But I want you to know that this is something that you can predict. I want you to predict. They not only take the data frame but also take the individual rule. Okay, in individual input value. Okay, so for example, if I just change, um, let's see what, you know, yeah, this is some value, right? This is, let's say, if I just change to 20 and let's see what happens. So, this is something that they predict based on your model, right? So if I've changed 20, right, then now it's a 1, right? 1 means what? 1 means no damage. Okay. Okay, so I guess this is good, right? Because you put the groundwater in a you put the high value for the groundwater, and now it's change what from mild to the no damage. But anyway, and this is something I want you to know, right? The predict function is quite useful, right? Okay, so I'm done with the this what LDA model. Right? In my next video lecture, I'm going to talk about the KNN. Okay, so thank you.